Alright, so part of trig is vector components, vectors and components. We kind of talked about vectors already. Um, I like to think of it as just a different way of navigating a city. So let's say we have one vector that goes a certain angle this far for 5 blocks. Okay. Now, actually, there's another way to go from this center point to the end point. If we go over 1, 2, 3, so that we're directly under it, and that we want 1, 2, 3, 4, we would have a 3, 4, 5 triangle. Now, I use 3, 4, 5 because it works out really nicely. But often, if you were to go over like 7 and then up 2, it's going to give you a really ugly decimal. But this is just to make a point. I could go at a certain angle here, and then I could go a certain magnitude and end up at a point, or I could go along city blocks here. I can go directly east and directly north to get where I need to go. So vectors, the way that you write them, this vector right here, if we call this vector u, this is how we write it. U with a little arrow on top. And we could also write it like this, 3, 4. This is called component form, because there is an x component and there is a y component. Okay, if I ever write like this, absolute value signs around the vector, that is the magnitude, or basically the length. So in this case, that would be 5, because it's a 3, 4, 5. 3 squared plus 4 squared equals 5 squared. So that's why it's 5. And so we need to be able to convert between the two. Okay, so if I ever, here are some formulas for you. If I ever give you just a vector like above, let's say I have a vector v, and it's 6, no, let's just go right to the formulas, x, y. So it's going over x, up y, and we need to figure out the angle and the magnitude. Then here's how you do it. The magnitude is going to be the square root of x squared plus y squared. This is actually the Pythagorean theorem in disguise, but that's how you do it. And then theta is going to be tan inverse of y divided by x. So to see how that works out, if I gave you, let's say, vector A, and we know that vector is over 2 up 5, excuse me. Now the picture is going to be like this. We would have over 2 and up 1, 2, 3, 4, 5. That's the vector. Now we need to know two things. We need to know the angle. We need to know the magnitude. So the magnitude, I keep writing r because that's the other way to write it. The magnitude is going to be where I take 2 squared plus 5 squared and square root. So that'd be 4 plus 25. That'd be the square root of 29. Now, as a decimal, square root of 29 is going to be a little over 5. That comes out to be 5.4-ish. Okay. Now, if I want to know the angle, I do tan inverse of y over x. So that'd be 5 over 2. So tan inverse 5 divided by 2, I get 68.2 degrees. So that's just an example with numbers, but these are the formulas for converting. If you have vectors and you need to go and if you have the components and you need to go and figure out the magnitude and the angle. Now there is another set of formulas if you want to go the other direction. if I have the magnitude, let's say the magnitude of A equals R, and I know the angle, let's just call that theta. Now to figure out the component form, this is how you do it. You do R cosine of theta, R sine of theta. So for example, let's say the magnitude of A, the length of A, is about 3, and theta equals 20 degrees. So it kind of looks like this. You have about 20 degrees, and you're going out 3. We want to know how far over is this, and how high is this? What are my x and my y's? And so we would do this. We would do 3 cosine of 20 and 3 sine of 20. And that would give our x and our y's. Now on my calculator, I'm getting about 2.8 and 1.0. So I would walk over 2.8 and I would go up 1.0 to get to the same spot instead of turning 20 degrees and walking 3 to that spot. Okay, so this is used quite a lot with navigation. Okay, so we're going to do one example with a navigation where we have a hiker. Okay, let me write this out. Okay, a hiker travels 3 miles due east and then 2 miles 32 degrees north of east. What is his distance from the start? Now this is actually 2 vectors. Travels 3 miles due east is 1, and then 2 miles 32 degrees north of east is another, and we're combining them. So the picture here would look like this. If this is his starting point, he would travel 3 miles due east, and then from there he would turn 32 degrees north of east, this means that way, and travel this way to end up at this point. So this is like vector A, and this is vector B. Now, to figure out the total length over here, what we're going to do is actually just add up the vectors and then figure out from our end vector, the end result, how far away they are. And so first, let's write out the A vector. Now, due east would be 0 degrees. And so if you think about it, there's no y value here, there's only an x. And so then that vector will be 3, 0. For B, we have to do a little more work. We have to use the formulas we just talked about. This is the magnitude because he's walking that distance at that angle. So 2 cosine of 32 degrees to sine of 32 degrees will give us our components. Now, gotta go to my calculator for this, but 2 cosine of 32 would be 1.7, 2 sine of 32, 1.1. So what this means is we first travel 3 east, don't go north at all, and then we travel 1.7 east, but also 1.1 north. Now, if we add those vectors up, what we get is 4.7, 1.1. And that is actually this endpoint right here. So that is 4.7, 1.1. Now to figure out the distance from the start all the way there, that is a magnitude. And so to find the magnitude of the sky, we're going to finally just use our magnitude formula. So that would be the square root 4.7 squared plus 1.1 squared. And I'm getting an answer of 4.8 miles rounded from where he started. And that is this distance right here, 4.8 miles.